Simplification and Approximation Part 2. You remember in the Part 1, we have completed the V BODMAS. And let me tell you, this is really important if you want to do basic calculations or basic expressions based calculations, right? The second thing, that is the concept based, is surds and indices. Let me tell you, this is really important if you are preparing for any of the exam, especially the simplification and approximation part. Sometimes surds and indices are also the part of time, speed, distance, arithmetic, or it can be under the time and work, or it can be in the arithmetic part as well. So when you talk about this topic as a subject, as a application part, it is applicable in arithmetic, applicable in DI, sometimes in a form of under root. You may get to see under root x or under root 5 or 2 under root 3. These kind of notations everywhere. It may be in arithmetic, it may be in DI, it may be in simplification. So before you get into those kind of topics or those kind of applications, let's develop the basics of surds and indices. What all the agenda today? I divided the overall session into 4 small parts. First, introduction to surds and indices. Let's understand what exactly meaning with the word surd or index or indices. Then we look at what is the importance of this, where all these things are applicable. Then there are some specific laws of indices and surds, as we have certain rules of multiplication, certain rules of addition, subtraction. We have certain rules for powers as well. Then we will do 2 or 3 practice questions to get an application part, to get an understanding of it. But let me make you one thing very clear. Just solving 1 or 2 questions would not be making you very used to of these concepts. If you want to get a command over it, practice not less than 25 to 30 questions over it, and you will easily get the questions of surds and indices from NCERT books or from any of the famous books available for exam preparation. Let me start with the first thing, that is module 1, that is a part 1 of the day, introduction to surds and indices. You must have seen the word surds and indices. When you say surds or indices, these are the technical meaning of this. Indices is the plural name, index is the basic name. Now, so when you look at what I mean with index, it is a power, it is an exponent or a number. So when you say indices or index, it is nothing but the power. And what is indices? It is plural form of index. So for example, I am writing x power 5, where 5 is the index of x power 5. Now let me tell you what is the exact meaning of x power 5. So what is the meaning of this? This is power. That means you multiply x as many as number of times as the power of x. So you multiply this x 5 times. Simple. Similarly, if I am writing x raised to the power 3, what is the meaning of this? You multiply x 3 times. Simple. For example, I say 2 raised to the power 3. What is the meaning of this? We already have learnt the powers. It is simply 2 into 2 into 2. So what is it? 8. I hope this is clear. This is what indices. This is what index. Now the problem starts when you have the power of 2 is 1 by 2. So would it be like you are multiplying 2 half times? So basically, whenever the power of a particular base is in decimal or is in fraction, we start calling it as surd. That is, in plural form, it is called surds. So what is the exact meaning of surd? For example, I am saying under root of x. The meaning of this is x power half. Okay. When I am saying cube root of x, what is the meaning of this? X power 1 by 3. So this is exactly the surds when the power is a fractional number or a decimal number, right? So we can also call these numbers as irrational numbers. You must have read this in your early age when you have studied about number line, real numbers. rational numbers, irrational numbers. But don't worry, for these exams, specific things, you no need to get much about irrational number, or no need to learn much about rational number. Okay, so you understand what is the meaning of this? This is 10 power 1 by 3. You understand what is the meaning of this 2 power 1 by 2. So I think when you see the surds and indices, technically whatever properties and rules we have for indices are also valid for surds, right? So although I'm saying these as different things, surds and indices, but they are well connected things. So let's see what are the importance of surds and indices. Okay, and then we will see that what are the basic properties and rules related to the indices and surds. So let's see the importance. If I talk about the importance part, it is applicable in simplification, as I have told you in the initial of the session. Simplification and approximation. Quadratic equations can also be based on surds, right? Something like this. I say x square minus 3 root 2, okay, plus let's make it 4 is equal to 0, something like this. Now we have to factorize this and get the value of x from here. So it can be visible in the form of indices, so in the form of quadratic equations. Sometimes you will get an equation like x cube is equal to 2197. So again we are getting the indices here. It may be surds, it may be indices visible in the quadratic equations. In quantity comparison, that we will be covering separately. This is one style of asking arithmetic questions, right? The question can also be based on surds and indices, applicable in data sufficiency, applicable in arithmetic problems. Okay, so it is applicable at various part of your overall quantitative aptitude as a subject. In the various topics it is applicable, right? So we cannot ignore this topic, even if you may not have a direct questions on this. You may not have a direct questions on this, right? Now, what I mean with indices and surds, that we already have discussed. Importance of surds and indices, we already have discussed. Now, let's see, is there any specific rules or any specific properties we have related to indices and surds? And this all we have studied in the early age. It is a quick revision kind of thing. You must be knowing when you are multiplying bases, powers are added. The condition for this is base has to be same. This is a basic condition. For example, you are multiplying 2 power 3 with 2 power 7. Since the base are same, you can say it is 2 power 10. Right? Now, let's say we have 2 power 4 into 3 power 4. Can I say it is 2 into 3, 6 power 4? Or can I say it is 2 into 3, 6 power 8? Which one is correct? Of course. The basic rule is, let me change the color. If base are same, operate the powers. If power are same, clear, operate the base. So here I multiplied the base. So it is basically powers are same, so I am operating the base. It is 2 into 3, 6. Simple. Just look at, if the base is same, operate on the powers. If powers are same, operate on the base. Let me show you this once again. Here it is division. What happened in case of division? Again, condition is base has to be same. So if division, powers are subtracted. Here power are same, so base are operated, they are divided. Something like if we have 2 power 4 divided by 3 power 4, I can say this is 2 by 3 power 4. Or I can make it even beautiful. I say 4 power 6 divided by 2 power 6. I can write this is 4 by 2 power 6. Or I can say this is 2 power 6. So what the simple rule is? Power is same, operate on base. Base is same, operate on power. Got my point? Now, and this is really important when you come into the simplification part. Okay, let me give you one more example. For example, you are multiplying 4 power 8 with 2 power 6. What to do? Neither the base nor the powers are same. So what to do here? I will try to make either the power same or the base same. Either of the two, whichever is convenient for me or whichever is required based on that question requirement. So if I write this 4 as 2 power 2, this is whole power 8 into 2 power 6. Here comes the importance of another property, which is this one. This is whole power. A power n power m. What is the meaning of this? Anyone knows? The meaning of this is very simple. What is the meaning of this? It is like a power n multiplied m number of times. A power n multiplied m number of times. So the meaning of this is a power n into. Okay. So now this is 2 power 2 into 8. So what is it? 2 power 16, 2 power 6. So it is 2 power 22. Right? So if you are operating something in the form of indices, you try to make the base same or you try to make the power same. Now, can it be done by making the power same? Yes. Look at what is the common in 8 and 6. Is there any common thing? HCF, what is the highest common factor of 8 and 6? Yes, that is 2. So I will write it as 4 cube whole power 2. Okay. And I will write 4 cube. Oh, great. 4 power 4 whole power 2. Or I will write this as 2 power 3 whole power 2. Now, what is this? Powers are same. So operate on base. 4 power 4 is 2 power 8 or it is 256. I have told you to learn the powers, right? And 2 cube is 8 whole power 2. So don't you think it is very, very calculative now? That's what I have told you, that based on the requirement, you can decide whether you convert into the same base scenario or you convert in a same power scenario. In this particular question, you yourself understand that converting the calculation into the same base scenario is comparatively easier than converting the calculation into same power scenario, right? So we have done the 1, 2, 3, 4, 5 properties of it. Now let's talk about this a power 0. Everyone knows a power 0 is always 1. Okay, let me explain why it is written a is not 0. Because 0 power 0 is not defined. 0 power 0 is not defined. So whenever I am saying a power 0, it is but obvious that a is not 0. What is a power minus 1? What is the meaning of negative power? The meaning of negative power is division. So it is a power minus n is 1 upon a power n. If you want to explain or want to understand it little logically, you say a power 0 minus n, or I can say it is a power 0 upon a power n, because in division power are subtracted. So it is 1 upon a power n. Right? I hope this is clear. Very much clear to everyone? All of us. So law of indices is clear. Let's see if these indices are now surds, will the properties change? So I think this is the one I already have talked about during the introduction of surds, right? Nth root of a is a power 1 by n. This is like power is same, surd is same, so we are operating this. This is also same thing. Clear? This is whole power kind of thing. So when you look at this part, let me see, it is a power n whole power 1 upon n. So it is a power n into 1 upon n. So it is a. Finished. Okay, same thing is here now. It is surd over surd. Basically it is whole power kind of case. Something like I say cube root of under root of a. So it is like a power 1 by 3 into 1 by 2. Clear? So it is a power 1 by 6. So it is 6th root of a. I hope this is very clear. No doubt. Okay. So these are the surds. These are the laws of surds. Let me explain this part once again. For example, you are multiplying under root 3 with under root 2. What is it? Using the same property from right to left, it is under root of 3 into 2. So it is under root of 6. Okay. Let me explain this property once again. If you are multiplying under root 2 with under root 2, so it is basically under root 2 multiplied 2 times, which is equal to 2 only. Okay. So I think we are gradually connecting that how to use the laws of surds. It is not always that I use them from left to right. We can also use them from right to left. Okay. We can also use it from right to left. Depending on the situation, depending on the requirement, I will choose it as per the question, right? Let's take it forward and let's look at some of the practice question. Let me make it one thing clear once again. You have to practice good number of questions after you understood what is all surds and indices. I am just showing you 2 or 3 examples to make you understand that what exactly or how exactly we have to apply the laws of surds and indices, as well as how to handle the surds and indices. But ensure that you attempt not less than 25 to 30 questions of surds and indices by your own after attending or after watching this particular video. This is the first question, guys. How to handle this? That's what I have told you. Learn the powers. I can write 27 is 3 cube whole power 2 by 3. Now you must be knowing the property of whole power. It is 3 power 3 into 2 by 3. So it is 3 power 2. So your answer is 9. I hope this is very clear. And if you know the properties, it becomes very easy for us, right? Especially in case of surds, it is very important. Let's look at this. 125 power minus 2 by 3. How to handle this, guys? Must be knowing the power of power of 5. 125 is 5 cube. Whole power means multiply minus 2 by 3. 3 and 3 cancel. So it is 5 power minus 2. Now you must have remembered a power minus n. What is the meaning of this? 1 upon a power. So same thing is here, 1 upon 25. I mean 1 upon 5 square. So answer is B for Bombay. Pretty clear, right? And this is clear if you have understood the basic operations of surds and indices. Let me show you the another one. Oh great, this 256, how to handle this? Do you know the power of 2? Yes. So when you look at this 256, maybe I can recall it is 16 square. Let's say I do not know the power of 2, or I can say, okay, 16 is 4 power 2 whole power 2. So it is 4 power 4. Right? And I'm stopping myself here only because I can see the denominator of this fractional power is 4 and this 4 and 4 will cancel. So I'm writing this is 1 upon 4 power 4 whole power minus 3 by 4. You very well remember what is the meaning of fractional term here. When you bring it upside, it will be negative power. So it is 4 power minus 4 whole power minus 3 by 4. Whole power are multiplied. We have already seen it, right? So it is minus 4 into minus 3 by 4. It is a basic operation. Now I can say minus and minus is plus. Just a minute. Minus and minus is plus and 4 and 4 is cancelled. So it is 4 cube or it is 64. I'm sure after looking at these 3 examples, you are very much aware that why learning powers is important. You are very much aware that how to use these properties, use these laws of surds and indices. Practice it from any NCERT book that contains this topic, indices and surds, if from 7th or 8th class. If you do not want to go back to your 7th or 8th class book, although it is very easily available, you can pick up any other booklet that has this topic of indices and surds for banking exams. It will help you definitely to improve your command over surds and indices. And this is really important that you practice not less than 25 questions of surds and indices after attending or after watching this particular video. Question number 4. This is really important question. What is here? 3 and 3. The base is equal. If base is equal, you can simply operate on powers. I have told you this. So here the powers are also equal. That means 3x plus 6 is equal to 6x. If you bring it here, it is 3x is equal to 6 or x is equal to 2. Once you get the value of x, that is 2, you can easily get the x power 5. What is x power 5? 2 power 5. So what is your answer? 32. Learn the powers. I have told you this many times so far and I keep on reminding you this, right? So this is a little demonstration of the application of surds and indices. I again repeat, practice not less than 25 questions of surds and indices from any available book with you. Okay, so we have completed 2 special sessions on this simplification approximation. Now it is a time to give a complete practice or to get a final session on simplification. So next session, this is a session number 3, will be on simplification. Stay tuned with us. We'll see you again, guys. Bye-bye.